When you look at a map of New Zealand, it's a sight to behold. Two magnificent long islands stretching out in the vast South Pacific Ocean. They look so close, don't they? The North Island, where you find the bustling city of Auckland, and the South Island, home to the majestic Southern Alps, almost seem to be reaching for each other. At their narrowest point, they are only about 22 kilometers apart. It's a distance that makes you wonder, almost immediately, why there isn't a bridge connecting them. Surely, in our modern age of incredible engineering, spanning that little gap would be a piece of cake. It's a question that many visitors and even Kiwis themselves have asked over the years. The body of water that separates these two landmasses is called the Cook Strait, named after the legendary explorer Captain James Cook, who was the first European to sail through it back in 1770. On a calm, sunny day, you can stand on the shores of Wellington and see the misty outline of the South Island across the water. It looks tantalizingly close, like you could almost swim it, though I definitely wouldn't recommend that. This deceptive proximity is what fuels the dream of a bridge, a massive structure of steel and concrete linking the country's two main parts into one seamless whole, making travel and trade easier than ever before. But the Cook Strait is no ordinary channel of water. It's one of the most unpredictable and downright dangerous stretches of sea on the entire planet. It acts like a massive funnel for winds whipping between the two islands, creating some truly wild conditions. What looks like a peaceful waterway on a map is, in reality, a cauldron of churning waves and ferocious gales. This isn't just a simple gap between two pieces of land, it is a battleground of powerful natural forces. The idea of placing a permanent structure right in the middle of this unpredictable arena presents a challenge of epic proportions, one that has stumped engineers for generations. So while the dream of a bridge is easy to imagine, the reality is far more complex. The distance might seem small, but the challenges packed into that short stretch are immense. It's not just a matter of building a long bridge, it's about building a bridge that can survive a constant barrage from Mother Nature at her most ferocious. We're talking about a structure that has to withstand more than just wind and waves. The real secrets to why no bridge exists lie hidden beneath the surface of the water and deep within the earth itself, making this a truly epic engineering puzzle. Let's talk about the weather in the Cook Strait, because it is legendary, and not in a good way. The strait creates a wind tunnel effect between the mountain ranges of the North and South Islands. Winds that are just breezy elsewhere can be funneled into furious gales here, sometimes reaching speeds of over 150 kilometers per hour. These aren't just occasional storms, they are a regular feature of the strait. Imagine trying to build, and then maintain, a bridge in what is essentially a permanent hurricane alley. The sheer force of the wind pushing against a massive bridge structure would be relentless, creating constant stress on the materials and a terrifying experience for anyone trying to cross it. This wind, in turn, whips up some of the roughest seas you will ever encounter. The waves in the Cook Strait can become enormous and chaotic, often swelling to over 10 meters high. They don't just roll in one direction either. Currents and tides clash here, creating a confused and violent sea state that is notoriously difficult to navigate. For a bridge, this means the support pillars would be under constant attack from tons of water crashing against them day in and day out. The corrosive saltwater spray would also be a major issue, working tirelessly to eat away at the bridge's steel and concrete, requiring a level of maintenance that would be incredibly costly and dangerous to perform. Then there's the tide. The tidal flows in the Cook Strait are incredibly powerful, some of the strongest in the world. Because the tide is at different times on either side of New Zealand, water surges through the narrow channel with immense force, creating strong currents that can reach speeds of up to 8 knots, which is faster than many people can run. These currents act like a river in the sea, constantly scouring and shifting the seabed. Any bridge foundations would have to be anchored deep into the seafloor, fighting against this perpetual erosion that would try to undermine their stability from the moment they were built. So, when you combine the hurricane-force winds, the giant chaotic waves, and the powerful scouring currents, you have a trio of challenges that makes the Cook Strait a uniquely hostile environment for any man-made structure. It's a place where nature is well and truly in charge. Building a bridge here isn't just about spanning a distance, it's about declaring a war on the elements. And in this particular battle, the sheer raw power of the wind and water presents an opponent that is incredibly difficult and perhaps impossible to defeat with modern engineering alone. If the weather on the surface wasn't enough of a challenge, what lies beneath the waves of the Cook Strait is even more daunting. This isn't a gently sloping, shallow sea. The strait is surprisingly deep, plunging to depths of over 150 meters in the areas where a bridge would need its longest spans. To put that in perspective, that's like trying to build the foundations for a skyscraper on the bottom of a deep lake. Building bridge piers that tall, strong enough to support a roadway while being battered by currents, is an engineering feat of an entirely different magnitude than most bridge projects ever have to consider. Complicating things further is the very ground the bridge would need to stand on. The seabed here isn't a nice, solid slab of rock. It's largely composed of soft, deep layers of sediment, mud, and sand that have been washed into the strait over thousands of years. Trying to secure the foundations for massive, heavy bridge piers in what is essentially thick, unstable mud is an engineer's worst nightmare. The piers would need to be anchored incredibly deep, going down hundreds of meters through the soft sediment just to find bedrock solid enough to hold them, a process that would be astronomically expensive and technically complex. But the biggest and most terrifying challenge of all is hidden even deeper. The Cook Strait sits directly on top of a major collision zone between two of the Earth's tectonic plates, the Pacific Plate and the Australian Plate. This makes it one of the most seismically active regions in New Zealand. The area is riddled with active fault lines, and earthquakes are a frequent occurrence. A bridge across the strait wouldn't just have to withstand storms, it would have to be able to survive a powerful earthquake where the very ground it's attached to could shift violently. Designing a structure of this scale to be earthquake-proof in such a volatile zone is a monumental task. When you compare this to other famous long bridges around the world, like the spectacular Hong Kong-Zhuhai-Macau Bridge, you start to see the difference. That bridge, while much longer at 55 kilometers, was built in relatively shallow, calm, and protected waters with no major seismic threats. The Cook Strait combines every single major challenge in one place: extreme depth, violent weather, powerful currents, a soft seabed, and intense earthquake activity. It's this unique and deadly combination of factors that elevates the problem from merely difficult to nearly impossible with current technology and a reasonable budget. Faced with such an extreme set of natural obstacles, New Zealand has long relied on a different solution to connect its islands: a fleet of large modern ferries. These ships are the workhorses of the Cook Strait, specifically designed to handle the rough conditions. They carry everything from passengers and their cars to campervans, freight trucks, and even railway carriages. For decades, these inter-island ferries have formed a reliable and effective floating bridge between Wellington on the North Island and Picton on the South Island. They are a vital part of the country's transport network, ensuring people and goods can move freely. The cost of building a physical bridge is the final, insurmountable hurdle. Estimates have consistently placed the price tag in the tens of billions of dollars. For a country with a population of just over 5 million people, this is an astronomical sum. The economic case simply doesn't add up. The cost per person to build the bridge would be enormous, and it's highly unlikely that toll fees could ever repay the initial investment. Periodically, the idea of a bridge resurfaces, but feasibility studies always reach the same conclusion. The project is technically perilous and economically unviable. The existing ferry service, by contrast, is a far more practical and affordable solution. So, what do New Zealanders think? While the idea of a bridge is a fun topic for discussion, most Kiwis accept the reality of their nation's geography. The ferry journey itself has become a bit of a classic Kiwi experience. On a good day, the 3-hour trip is incredibly scenic, offering stunning views as you depart Wellington Harbour and navigate through the beautiful Marlborough Sounds on the approach to Picton. It's seen as a part of the adventure of travelling through the country, a moment to relax and appreciate the incredible landscape, rather than simply rushing across a concrete roadway. Ultimately, the absence of a Cook Strait bridge is a powerful reminder of the immense power of nature. It shows that even in the 21st century, there are some places on Earth that defy our grandest engineering ambitions. The unique combination of violent weather, deep water, a soft seabed, and seismic fury makes this small stretch of water a true giant of a challenge. For the foreseeable future, the trusty ferries will continue to sail the Strait, a testament to a practical solution in the face of one of the wildest and most untamable waterways on the planet.